In this video, we'll be working with linear equations with one solution, infinitely many solutions, and no solutions. The first thing we're going to discuss is the structure of these equations, and that basically just means how these equations are formatted. So an equation with only one solution, the only thing that will be the same in these types of equations will be the variable. The coefficients, which are represented by A and C, will be different. Also, the constants, which are represented by B and D, will also be different. Next, we have equations that have infinitely many solutions. And in my opinion, these are the easiest because both sides will have the same exact expression. So as you can see in the structure, both the variable and the constant are exactly the same. Last, we have equations that have no solution. Now, if you notice, the variables are the same in these types of equations. The only difference is that these equations will have different constants. Now let's look at an example of each one of the solutions. So we have the equation 9m minus 6 equals 6m minus 9. Can you guess, without solving, what type of solution this equation will have? If you find it challenging to recognize the structure of the equation, you still can find out how many solutions the equation will have by solving it the way we solve linear equations. So what you need to do first is identify the smallest variable, and then you're going to use the inverse or opposite operation to combine the like terms. Since we have 6m as our smallest variable and it's positive, we want to subtract 6m on both sides of the equal sign. Now we have the equation 3m minus 6 equals negative 9. Next thing we want to do is combine our constants, but also remove the constants from the same side as the variable. The minus sign in front of the 6 means this 6 is negative, so we have to add 6 to both sides of the equal sign. So our new equation is 3m equals negative 3. And our last step will be to isolate the coefficient from the variable. Remember, anytime we have a coefficient in front of a variable, that is the same thing as a multiplication problem. So I need to use the opposite operation, which would be division, to isolate the variable from the coefficient. So we divide both sides of the equation by 3. So m equals negative 3 over 3, which is a fraction that can be simplified. So negative 3 over 3 simplifies to negative 1. So this equation only has one solution. Next equation we have is negative 4x plus 5 equals 5 minus 4x. Are you able to identify the structure of this equation? If not, you can go ahead and solve it to see how many solutions we should have. So we still want to start off trying to combine our like terms. Well, in this situation, we have the same exact variable. We still should follow the same steps to combine those variables by using the opposite or inverse operation. So we're going to add 4x to each side of the equation. Once we do that, that leaves us with 5 equals 5, and your work is done at this point. Anytime you have an equation that ends with both sides being equal to the same thing, that means that this was an equation that has many solutions. Now, what this means for this equation is that we can substitute any value to go with x, and you're still going to have the same answer on both sides of the equal sign. And for our final example, we have 10r minus 2 equals 10r plus 1. Can you look at the equation and guess what type of structure we have? If not, Just follow the steps that we use to solve any equations, and you should be able to see in your final step what type of solution this equation should have. So again, we have the same variable on each side of the equal sign. Since they're positive, we want to subtract by the inverse, which is 10r. Now my new equation is -2 equals 1, which is not a true statement at all. So what this means is this equation does not have a solution. If you found this video helpful, don't forget to hit that like button and subscribe to the channel, and I'll see you on the next video.